Hello everyone. Let's try one more problem. A motor car is moving with a velocity of 108 km per hour and it takes 4 seconds to stop after the brakes are applied. Calculate the force exerted by the brakes on the motor car if its mass along with the passengers is 1000 kg. So here we need to find the force exerted by the brakes. So let me take a car. So I made a diagram of car at here. So this is the car. So this car is initially it's moving. So it's moving. So let this car is moving. Oops. So this car is moving. It's moving with an velocity. So they are given that velocity v equal to, so that is I will take as initial velocity since car is moving, so 108 kilometer per hour. So this initial velocity we will convert into meter per second. 108, 1 kilometer is 1000 meters and 1 hour contains 3600 seconds. So initial velocity u equal to 108 times. If we can do this calculation, so it will becomes 5 by 18. So 10, 5 times 36, 18 times. So 5 upon 18. So meter per second. Now if you do for initial velocity in terms of meter per second, 108 times 5 by 18. So we try to cancel 9 table, 2 nines are 18. So 1 nines are 9 and 2 nines are 18 and 2 in 16, sorry 12, 6 times. So I got finally initial velocity u equal to 30 meter per second. So this is the car initial velocity in terms of meter per second. Or if you remember, to convert kilometers per hour into meters per second, we need to multiply with 5 by 18. So that gives the value of meter per second. Now mass of car, given car mass equal to 1000 kg. Now in the second case, after applying brake, now if I take this case at here, now so this is the case after applying brakes. So if the car having initial velocity u, if you apply brakes, what happens? So the car will becomes to rest. So this is the brakes are applied, the car comes to rest. So car took comes to rest, car took time t equal to 4 seconds to comes to rest. So that is the time. So what is the final velocity here? Final velocity v when it is at rest equal to 0 meter per second. So the final velocity of car, so in this case 0 meter per second. So this is the final velocity. Now to stop the car, who applied force? Somebody has to apply force to stop the car. So who applied force? Brakes applied force. Brakes applied force. So that force equal to how much? That's we need to calculate. So from Newton's second law, what we know from Newton's second law, F equal to ma. So calculate the force applied by the brakes. So we need to first calculate acceleration. From first equation of motion, v equal to u plus at. So if you can rewrite v minus u upon t equal to acceleration a. So we know the initial velocity and final velocity and time. So here time equal to 4 seconds. So let us calculate that acceleration first. So final velocity here is 0 minus initial velocity. I got 30 meter per second. Yeah, initial velocity is 30 meter per second upon time. So time here I got 4 seconds is equal to acceleration. So we can calculate that minus 30 upon 4 meter per second square which equal to acceleration. So this is the acceleration value, we got it. So here I am not simplifying it here. So everything I will substitute in the force, and I can do simplification. Therefore we can substitute that acceleration a value in this equation, F equal to ma. Therefore force applied by the brakes F equal to, mass is given, mass of the car 1000 kg, and here the acceleration we got that value minus 30 upon 4 meter per second square. Okay, now let's simplify. F equal to 1000 times 4. First we can multiply on the numerator, that will becomes minus 30 times 1000, it will becomes 30,000 upon 4 kg meter per second square. So if we can cut it here, so 30, 40, 4 in 30. So 4 in 30 equal to 7. Roughly it will become 7,500. So the force applied by the car, for the total, the force applied by the car F equal to minus 7,500 newtons. So here you are observing negative sign. So here negative sign tells about to stop the car, that is the amount of the force which is applied, means the force is applied due to the opposite to the acceleration. So finally we can conclude that the force applied by the brakes, which F equal to minus 7,500 newtons. If I write about negative sign, so here minus sign, negative sign, tells about the force applied by the brakes, the force applied by the brakes is opposite to the direction of direction of motion of the car. Yeah, car is moving the forward direction, but when we apply brakes, so that is the opposite to the direction of the motion of the car. So that's the meaning of the negative sign at here. Let's see one more problem. The velocity time graph of a ball of mass 20 grams moving on a straight line on a long table is given in figure. So what we need to calculate at here? Here we need to calculate how much force does the table exert on the ball to bring it rest. So a graph is plotted between velocity versus time for a moving ball on a long table. So because of friction between the ball and the table, the ball comes to rest. So we need to calculate the force does the table exert on the ball to bring the rest. So I am having a tablet here. So let me draw the diagram first. So this is my table. Suppose if I consider on this table a ball is rolling. Now let me draw a ball. Suppose this is my ball. So this ball is rolling on the table. It's just rolling. So this ball mass of the ball is equal to 20 grams. And since it is rolling and finally it came to rest at here. So this ball became at rest. It came to rest. And from the graph if you can see how much time it taken from roll from here to here. If this is the initial position starting and this is the final position. And initial position if you can see when time t equal to 0 initially in the graph, the ball having velocity 20 centimeter per second. Therefore, initial velocity u equal to 20 centimeter per second. Now they are given in 20 centimeter per second. And final velocity. So from the graph you can see final velocity after time t equal to 10 seconds. So this line is touching to 0. Therefore, final velocity, since it is coming to rest, we can understand the ball is coming to rest. So it's the final velocity equal to 0. Now, how much time it took to come to rest? Time taken to comes to rest. Time t equal to 0. Sorry, time here 10, not 0, it's 10. Because from the graph here you can see from t equal to 0 to t equal to 10 seconds. So the line came from the 20 centimeter seconds to 0. So that is the time 10 seconds. Now we need to calculate what is the force exerted by the table. We need to calculate force exerted by the table on the ball. So force equal to how much? So we will use the same formula, F equal to ma from Newton's second law. So if you can take it here from Newton's second law, from Newton's second law, but the Newton's second law, F equal to ma. So here acceleration same from first equation of motion, v equal to u plus at, and acceleration a equal to v minus u upon t. So we will substitute that F equal to m times acceleration. We can substitute those values at here, v minus u upon t. Now we can substitute the values. The mass is given 20 grams and the final velocity we have 0 minus initial velocity 20 centimeter per second upon time. Here it is 10 seconds. Now let us simplify this. So better take it out the units so we can do it easily. So therefore F equal to 20 of 0 minus 20, I can get minus 20 upon 10. So this is the force. I can get everything grams centimeter per second square. Okay. Now if you can calculate this one, I am not converting the units, so simply I am calculating it here. The force F equal to minus 40 grams centimeter per second square. But we need to express force in terms of newtons. So I am leaving a task to you. You please convert this force in terms of newtons. So for that you need to convert the grams into kg and centimeters into meters. So I hope you know that. So 1 kg contains 1000 grams and 1 meter contains 100 centimeter. So if you can convert that in terms of grams to centimeters, and this will be changes. I don't do calculations, but I will substitute and leave the calculations to you. Minus 40 in the place of gram. So if 1 kg equal to 1000 gram, so therefore 1 gram equal to how many kgs? So if we can write 1 gram equal to 1 by 1000 kg. So in the place of 1 gram, now here I can substitute 1 upon 1000 kg. Unlikely 1 centimeter, sorry, 1 meter contains 100 centimeter. Therefore 1 centimeter equal to 1 over 100 meters. Now in the numerator you can convert that 1 over 100 meters upon second square. Now this is the calculation I am leaving to you, so you can solve it by yourself and find out the force in terms of newtons. Now here again we got the sign is negative. What the negative sign tells about? The negative sign is the force applied in the opposite direction. In the opposite direction of the motion. So when the ball is rolling in the forward direction and the force applied by the table, so here that force is the friction force. You just remember that. Here the force present between the ball and the table, and this force we call it as friction. So the friction force always in negative because it will be opposite to the direction of motion of the ball. So that's why the negative signs tells about the force applied by the table is the opposite to the direction of the motion.